So whether you borrow from second octet or third octet or fourth octet, when you borrow 3 bits, the increment value is going to be only 32. Since you have borrowed from the fourth octet, 32 is the fourth octet. But you should not think that this is an invalid network. No, it's not like that. A network can also be 32, 0.32. And what will be the new subnet mask? The default subnet mask was 24. Now, after subnetting, the new subnet mask will be +3, isn't it? 27. So this is one way of writing. What is the other way of writing? 255, 255, 255, 224, isn't it? Right. Even the subnet mask can be like this. Subnet mask, it doesn't need to be always 0. Whatever the bits that you have given for network, you need to mention it. That is what subnet mask is. Yeah. Some people think that network means it should be 0 here. Subnet mask means there should be 0 at the last. These are all their imagination. These are all their misunderstanding. They imagined. It's not true. Okay. The next network is 192.168.0.64. 96. 120. And then, am I writing correct? Yeah, 120, 160, 192. And then 224. I told you if it is 224, you should not use because all three are 1. When all the borrowed bits are 1, you should not use it. It's not valid. Now count and see whether you have 7. 1, 2, 3. The seventh network is 192.168.0.192. So for 7th department, you have 7 subnets. As you know already, the IP address the first IP address is going to be 1. What is this? 192.0.1. And the broadcast is going to be 31, isn't it? One number before this. That is broadcast IP. The last IP will be see how many IP addresses you get in this one network. Exactly 30 IP addresses. In each department, I can have up to 30 computers. Do you understand that? 0.1 will be given to the first computer. 0.2 will be given to the next computer. Up to 0.30 is the maximum. You understood? Have you finished writing the entire stuff? Okay. No need to write all of them. No. Have you finished all these things? Write it now. Then I'll do, and then you can copy or correct it. All right. You finish it fully. You see, because the network is 32, the first IP address will be 33 only. There should not be any doubt. We should not think like, how can a first IP address be 33? No, in subnetting it is possible. And here it will be 65. And this will be 95, 97. This will be 129. This will be, yeah. And then the broadcast will be for this one. The broadcast will be exactly 162. If you count and see here, even this will give you 30 IP address, including 33. When you count, it will be 30 IP address. Next. This is 96, so here it's going to be 95 and 94 here. 128, so this is going to be 127, 126. Yeah, I think you have done all this correct. You've got the clear picture of what subnetting is, isn't it? The last one, 192.168.0.222. The broadcast will be 223. Am I right? Okay. If you have done this, we can move to next level. But I would like to give you another exercise before I go to next level. This one you will do without any second thought. Okay, you should do without any doubt. Straight. Okay. So number of departments are 3. Do it. The new subnet mask is 26 because the default mask is 24. You might have borrowed 2 bits for 3 departments, correct? Okay. So how do you write this to 26? 255, 255, 255, and then what? No, sir. I mean 26 bit for networking you have. 24 bit default, 2 additional bit you have given. So totally how many bits we have for networking now after subnetting? 26 bits. So this 2 bits that you have borrowed, what will be the total value? Sir, in this octet you borrow 2 bits, no? Okay. You see 200, 0, 0. This is network. It is masked. Why it is masked? Because it is class C. So you can only borrow from this octet, isn't it? The last octet. How many bits you borrow? 2 bits you borrow. So totally how many bits are now for network? No, sir. Because of class C, already 24 bit. Another 2 bit is 26, isn't it? Now tell me, what is the value here? This face, no, this face value is 64. This face value is 128. When you add these two, you will get 190. We have to add and put, no? Look at this. This is how you put the previous one. You see, 224. How you got 224? Because in this 3 octets you have given for network. 128, 64 plus 32. What do you get? 224. Now you did not give 3 bits. In the new problem, you have given only 2 bits. When you have given only 2 bits, the sum of the first two face value is 128 plus 64, which is 192. கொஞ்சம் எல்லாம் மறந்துச்சுன்னு நினைக்கிறேன் உங்களுக்கு. இப்போ இது புதுசா யோசிக்கிறீங்க. நல்லா ஹோம்ஒர்க் பண்ணீங்க. ஹோம்ஒர்க்லாம் நல்லா பண்ணியிருந்தீங்க. அதனால தான் நான் okay, let us take him to next level நினைச்சு I brought you, but it is no problem. Okay, so after the class you watch the video, you will be clear. எத்தனை பிட் நெட்வொர்க்கிங்க்கு கொடுத்துருக்குறோமோ அதுதான் சப்நெட் மாஸ்க். நீங்க சப்நெட்டிங் பண்றதுக்கு முன்னால 24 பிட் கொடுத்துருந்தாங்க, ஏன்னா இது கிளாஸ் சி. அப்போ சப்நெட் மாஸ்க் எப்படி எழுதுவோம்னா 255 மட்டும் தான் எழுதுவோம். ஏன்னா 24 பிட்ல அதான் வரும். 8 + 8 + 8 பிட். மொத்தம் 8 பிட்டையும் கூட்டினீங்கன்னா 255. இன்னொரு 8 பிட்டு கூட்டினீங்கன்னா இன்னொன்று 8 பிட்னா மொத்தம் 24 பிட். அதை இப்படிதான் எழுதுவோம். இப்போ 24 பிட் இல்ல 26 பிட். அப்படின்னா இங்க இருக்கிற 2 பிட்டை கூட்டணும். இங்க இருக்கிற 2 பிட் கூட்டினீங்கன்னா இந்த பிட்டையும் கூட்டினீங்கன்னா இந்த பிட்டினுடைய வேல்யூ 128, இந்த பிட்டினுடைய வேல்யூ 64. 128 plus 64 is 192. So this is what we call as new subnet mask. This way of writing subnet mask is what called as classless interdomain routing notation, CIDR notation. Classless interdomain routing notation. Okay, now 200.0.0.0. Okay, you may write optionally here 26, but you have written on the top, so you don't need to write for every subnet. 200.0.0.64. இதெல்லாம் நீங்க சொன்னீங்க கரெக்ட் தான். 200.0.0.128 26. இன்னொரு 64 கொடுத்தீங்கன்னா 192 வந்துடும். 192 நம்ம யூஸ் பண்ணக்கூடாது, ஏன்னா 192 2 பிட்டையும் கூட்டினா 192 வரும். 2 பிட்டும் இப்படி ஒன்னா இருந்துச்சுன்னா நம்ம யூஸ் பண்ணக்கூடாது. ஆல் ஒன்ஸ் வி டோன்ட் டேக். ஓகே, இதுக்கு மேல போகக்கூடாது. ஸோ வி நீட் 3 subnets for 3 departments. We already got it. And now what will be the first IP address of the first department? 200.0.0.1. And the broadcast will be 200.0.0.63. And the last will be 200.0.0.62. Then here 200.0.0.65, 200.0.0.127, 200.0.0.126, 200.0.0.129, 200.0.0.191, 200.0.0.190. This is what the answer is. Got it? Huh? Set. This protocol ARP, Address Resolution Protocol, Address. You know it already? Have you heard this? Oh, okay. Do you know why it is used for? No problem. Okay. Okay. I'll just remind you this topic. This is an important topic. We might have covered earlier, but I want to repeat once again for you to recall. Address resolution protocol. Now, if you take any computer, not only a computer, it can be even a router, but I want to just draw a computer to make it simple. When you have many computers, or even if you have just two computers, the ARP is very important. You see, I have many computers. To connect all of them, I have a LAN device. See, it forms a LAN, local area network. So switches are called as LAN device. It helps to connect like this. Now, we have IP address here, 10.0.0.1, 10.0.0.7, 10.0.0.2, 10.0.0.3, 10.0.0.4, 10.0.0.5. Now, these are all IP address. See, for communication, IP address alone is not enough. You also need IP address. Sorry, MAC address. Every device have got MAC address. You remember the size of MAC address? What it is? No, what is the size of MAC address? Correct. It is 48-bit size. It is 48-bit size. What is the size of your phone number? 10 digits. That's the size of your phone number, 10 digit. With the code and all, it may be more. Like if for India plus 91, so it will be like 12. So anywhere on earth you go, you will not get any phone number more than 12, including country code. It's a standard. 12 digit phone number is a standard, including the country code, area code, all code. Likewise, if it is MAC address, only 48 bits always. It never increases nor decreases. If it is IP address, only 32 bit. If it is version 4, which we are doing now. What version we are doing now? IP version 4. We will also be learning IP version 6 bit later. That one is 128. Remember these numbers. Important. 48 bit is MAC address. 32 bit is IP address. See, easy to remember 48 bit. 4 double panna 8 or. Yeah, 48 bit. இந்த 4 and 3 multiply பண்ணா 12 வரும் இல்லையா அப்படிலாம் வேண்டாம் 4 ஐட்டம் டபுள் பண்ணா 4 டபுள் பண்ணா 8 வரும் so that is MAC address. Okay, so now I don't want to write the big MAC addresses of 48 bit. Just for our easy writing, I'm going to write the MAC address of this one as AAA, BBB, CCC, TDD. Assume these are all MAC addresses of these computers. Now, if A wants to communicate to C, what is the source IP address? What is the destination IP address? 10.0.0.5. See, in this computer, you will go here inside and say ping 10.0.0.5. So this computer now knows the source address and the destination address, isn't it? தன்னுடைய அட்ரஸ் தான் சோர்ஸ் அட்ரஸ். யாரை பிங் பண்ணணும்னு சொல்றோமோ அதுதான் டெஸ்டினேஷன் அட்ரஸ். உங்க கம்ப்யூட்டருக்கு தெரிஞ்சிடுச்சு அது. அது மட்டும் இல்ல, கம்ப்யூட்டருக்கு தெரியும். Your computer also knows the source MAC address is AAA because it is its own MAC address. But it do not know the MAC address of 10.0.0.5. உலகத்தில் இருக்கிற எல்லா கம்ப்யூட்டர்னுடைய மேக் அட்ரஸும் நம்ம கம்ப்யூட்டருக்கு எப்படி தெரியறதுக்கு வாய்ப்பு இருக்கு? வாய்ப்பே கிடையாது. Not possible, right? Sometimes we don't even remember our new SIM number. The one phone number that you got 10 years before you remember. But later you bought some SIM cards and we never, not only you, me, we never memorized it. I never do that. But I do use 2 SIM cards. The second SIM card number, I don't know. Now, how will the computer know all the MAC address of this network? Not possible. So we need a protocol to learn the MAC address. See, if you take OSI layer, it has got 7 layers. All 7 layers should put its properties, its details. Only then the packet can be sent over the network. If I don't know the MAC address, this packet cannot be sent. We need to know the MAC address. For that, what ARP will do, when there is no MAC address in the MAC table, this ARP protocol will try to find it out and give it to your computer. See, you're pinging 10.0.0.5. It will, first of all, this PC will go and check the ARP table. Do you have MAC address for 10.0.0.5? The computer will say no. Then immediately ARP will come in picture. ARP will say, let me find it for you. Ping, don't worry, ping. I will find it for you. நான் உனக்கு கண்டுபிடிச்சு தரேன் பிங். உனக்கு என்ன வேணும் சொல்லு. மேக் அட்ரஸ், யார் மேக் அட்ரஸ் வேணும் சொல்லு. ஓ 10.0.0.5 அவ்வளவுதானே, அது என்கிட்ட விடு, நான் பார்த்துக்கிறேன். So what this ARP will do, it will send a packet with broadcast address FF 12 times F. Do you remember we learned this in the beginning? 12 times F. What is this address called as? Layer 2 broadcast address. It will send the packet to this address. Putting this address, it will send the packet. If the packet is broadcast address, switch will send the packet, a copy of it to everyone. As soon as switch receives the packet with this as a destination MAC address, switch will forward a copy of that same packet to everyone. Don't think that one packet only will go to B and then come back, go to F, come back. No, not like that. Switch will take a copy of that packet, send it to B, C, D, E, and F, all of them. Now, F will open this packet. F will open the packet because the address is what? Address is a broadcast address. Broadcast address, it's for everyone. So F says, I am also one among the everyone. Let me open the packet. It will check the IP address, but the IP address don't match. Then F will drop the packet. Likewise, E also will drop the packet, D also will drop the packet, B also will drop the packet. Who will accept the packet? C will accept the packet. And now, after layer 3, in layer 4, the payload says, means our message will be there, not in layer 4, it will be there in the layer 3 above. The message says, I need to know the IP address of your computer. Sorry, I need to know the MAC address of the computer whose IP address is 10005. Then this computer says, okay, I'll give you my MAC address. So this gives the MAC address. Now, this is ARP request. ARP reply will be ARP reply from C to A will be source is what? 10005. Destination is who? 10001. Source MAC address is what? CCC. Destination is A. That's it. So in the payload, it will also say 10005 MAC address is CCC. Now, when this packet goes to computer A now will write to the ARP table. It will say that 10005, I learned the MAC address, it is CCC. Now, கண்டுபிடிச்சிட்டேன் 10005 உடைய MAC address வந்துங்க CCC. This is what we call it as ARP table. In ARP table, this mapping you can see. It's a important protocol which will be widely used for every conversation. Without MAC address, you cannot do the conversation successfully. So you need ARP support to learn MAC address for the conversation to be successful, right? So we have learned today the subnetting, but subnetting is still there. We have not finished. We learned subnetting with the class C address today. So that was a new experience for you because the addresses were ending with 63, 95, 127 as a broadcast, which you have not seen before. And the network is like 32, 64, 96. First IP address is like 65, 97 and all. For you, it was a new experience. I want you to go through this. I do not want to go to next subnetting level with confusion. So we just revised ARP. Yeah. See you then tomorrow.